Hello learners, I am Dr. Nidhi Mathur, PhD in Public Administration and teaching at Institute of Management Technology, Center for Distance Learning, Ghaziabad. The subject expert is Dr. Neeti Mathur, teaching in National Law University, Jodhpur, Rajasthan. Previously, we discussed linear programming in operations research. Our topic of discussion for today is sensitivity analysis. Let us begin with understanding of meaning of sensitivity analysis. Sensitivity analysis in general is a technique used to determine how different values of an independent variable influence a particular dependent variable under any specific set of assumptions. It is the study of analyzing how a given mathematical model gets affected by various sources of uncertainty in that model, where the technique is used within defined boundaries depending on one or more input variables. In this way, it deals in finding out the change in the output of our model when the input data is changed and determines how the model can remain comparatively unchanged. It shows us how much each assumption matters to the result and why, offering us guidance to figure out the most advantageous expansion of the model and helpful in obtaining more data. Sensitivity analysis is used in various activities or systems in business world and in the field of economics. It is also known as what if analysis or simulation analysis, commonly used by financial analysts and economists. It is also useful in other fields such as geography, biology, engineering, chemistry, social sciences, environmental, etc. Working principle. Sensitivity analysis works on the basic principle of changing the values of independent or uncertain variables in a given model, influencing the values of other dependent variables and observing the behavior of the model if the output varies significantly when the input variable is changed from its minimum to maximum range, then the output is said to be sensitive, and if it does not change much, it is said to be insensitive or robust. In other words, it works by changing a certain range of variables given and predicts the outcome of a decision. The following parameters are required to be kept in mind while analyzing. Experimental design. A combination of parameters that needs to be varied at a given point in time are included. Maximum and minimum values are assigned to these included parameters before the experiment to study the correlations, both positive and negative, and the combinations are assigned values accordingly. What to be varied? The various parameters to be chosen to vary could be the number of activities, the objective with reference to the risk assumed and the profits expected, number of constraints with their limits, technical parameters, what to be observed. Certain things to be observed are value of the objective as per the strategy, value of decisive variables, value of the objective function between two or more strategies acquired. To understand the pros and cons of a model better, sensitivity analysis is applied repeatedly. This way, it helps in quantifying the risk and identifying the parameter settings and strengthens the credibility of the model. For recommending an approach or a model, this information is very crucial. It estimates the accuracy of a model by understanding its behavior and implications and verifies if the model is working the way you expect. Measurement of sensitivity analysis. The following steps are used to conduct sensitivity analysis. Number 1, it starts with defining the base case output, say the net present value NPV at a particular base case input value V1 for which the sensitivity is to be measured, keeping all the other inputs of the model constant. Number 2, then calculate the value of output at a new value of the input V2, keeping other inputs constant. Number 3, determine the percentage change in the output and the input. Number 4, divide the percentage change in output by the percentage change in input to calculate the sensitivity. The process of testing sensitivity is repeated for other inputs while keeping rest of the inputs constant, and sensitivity figure for each input is obtained. In this way, we determine the change in output with respect to all the inputs separately and how sensitive the output is to change in various inputs. It helps in discovering where it is most worthwhile to spend more effort to obtain better estimates and expand the model. Methods of sensitivity analysis. There is wide variety of methods for sensitivity analysis. Every method differs in terms of application effort and the number of times it is required to be repeated. Several methods are designed for models encoding uncertainties using probability distributions, and some methods are designed for models with precise decisions and definite objectives. The various methods are parametric analysis for one variable. It is one of the simplest ways to analyze Sensitivity of a model. In this, we replace the definition of any scalar input variable such as a decision, chance or normal variable with a list of numbers. Select the node of a variable x in its parent diagram and show its definition in the attribute pane in the bottom of the diagram window. Select the list of numbers from the x plus y menu. Enter 3 or more alternative values starting from the lowest conceivable value up to its highest conceivable value and check the result. The base assumption here is that the actual result depends upon the parametrically varied variable. The effect of the parametric variations is displayed as a table or graph. The nature of the relationship can be seen by looking at the graph. For example, does increase in x causes increase or decrease in y? Is the relationship linear or non-linear? Is it monotonic, that is, the slope is positive or negative? Is there a minimum or maximum of y over x? Is the relationship complex, etc.? Parametric analysis with multiple inputs. With 2 or more variables, the parametric analysis is extended by selecting another scalar input variable z and replacing that by a list of values in increasing order. The graph of y now shows multiple lines in different colors for each value of z, or it shows a function of z for each value of x. The nature of relationship now shows if there are interactions between x and z, then the lines will not be parallel. If the lines diverge, it shows synergistic effects, and if the lines converge, it shows counter synergistic effects. The parametric analysis is also done with more than 2 variables. However, with additional dimensions, it becomes difficult to compare the results. Range sensitivity analysis or tornado chart. Range sensitivity analysis or tornado chart is used for a model with multiple uncertain variables, and the effect of each variable is analyzed by varying them in their range from low to high, and the rest of the variables are kept at their base or mid value. All the assumptions on input numbers which are uncertain is identified in the start, and the base or mid value is provided along with a conceivable low and high value enclosing it. The variables are put vertically on a chart according to the width of their range on the result from high to low. It forms a shape like a tornado and hence named tornado chart. Spider chart. Spider chart is similar to tornado chart, and it shows the effect on a result of varying each uncertain input over the range while keeping the rest of the inputs at their base value. However, the result is plotted on y axis while plotting variations of each input across the x axis. Since the parametric lines for each input crosses at their mid values, the result looks like a spider, where the number and direction of its legs depends on the number of variables. As it varies only one input at a time, the effects of interaction between inputs is not shown in a spider chart. Importance analysis. Important analysis is used to determine the level of uncertainty in the result due to uncertainty in each input. In this, the uncertainty in each input is expressed as a probability distribution. It is used to set priorities on uncertainties by determining the most affecting uncertainties, and the efforts can be made to reduce it by obtaining more information, or if that is not possible, then by doing more background research and obtaining estimates from sources. The estimated probability distribution can be refined for the most affecting uncertainties. The rank order correlation of the result with each uncertain input as a metric of importance is used in this analysis. Decision switchover graph. The analysis is used to determine the value of an uncertain parameter at which the preferred decision is switched from one option to another. In this, an uncertain input parameter x, a discrete decision variable with two or more options, and an objective to minimize or maximize is specified. As x varies from high to low, the value of the objective or its expected value in case of probability distribution for each decision option is graphed on the chart. Decision heat map. A heat map chart in general is used to represent data in tabular format with user defined color ranges such as low, average and high. In sensitivity analysis, to visualize which decision to choose as a function of two input parameters, decision heat map is used. The values of two parameters are plotted on the vertical and horizontal axis. By joining lines using the plotted values on both the axes, rectangle for each option is drawn and the color in each rectangle identifies which option has the highest value for a discrete decision with two or more options. EVI, EVPI and EVSI. This method works on the principle of estimating the value of information before obtaining the actual information. The increase in expected value due to obtaining information about an uncertainty quantity is measured as expected value of information, EVI. The increase in the expected value, if we learn the exact value of quantity to eliminate the uncertainty, is called as expected value of perfect information, EVPI. The expected increase in value of quantity that is obtained from gaining access to a sample of additional observations before making a decision is called as expected value of sample information, EVSI. The uncertainties are expressed as probability distribution. These measures are used for the models that include explicit decision variables and a numerical objective defining the value or utility to be maximized or loss to minimize. EVIU, the expected difference in the value of a decision based on the probabilistic analysis and a decision based on ignoring the uncertainty is measured as expected value of including uncertainty, EVIU. It helps in evaluating the benefits of allowing for uncertainty in the decision. Advantages of sensitivity analysis. Let us now discuss the advantages of sensitivity analysis. There are multiple aspects that benefit from sensitivity analysis, such as in-depth analysis of a model or a scenario, strengthening weak spots of a model decision making in businesses and organizations, and even in quality check of a model, etc. Sensitivity analysis has number of benefits for the fields, models, situations and scenarios it is applied in. Sensitivity analysis is the key for indicating the sensitivity of simulation to uncertainties in the input values of the model. Sensitivity analysis helps in evaluating the risk involved in a strategy. When an expected situation turns out to be different, sensitivity analysis enables the prediction of an outcome of a decision. Sensitivity analysis helps in identifying and measuring the dependency of the output to a particular input value and thus helps in reducing uncertainties from the system. Sensitivity analysis aids finding errors in a model and helps in taking informed and appropriate decisions. The predictions made through sensitivity analysis are very reliable as it acts as an in-depth study of all variables. Sensitivity analysis adds credibility to any type of model by testing the model across a wide set of possibilities. It helps decision makers to identify the required scope of improvement in various directions by analyzing the model. This way, it helps decision makers in making sound decisions about companies, business operations, manufacturing or production and the economy in general or their investments, etc. Disadvantages of sensitivity analysis. There are several disadvantages of sensitivity analysis considering the fact that it is based on assumptions and it is not relative in nature. Sensitivity analysis is based on historical data and management assumptions, and if the assumptions are wrong, the whole analysis will be wrong and predicted outcomes will not be accurate. Sensitivity analysis tries to determine the outcome by considering each variable input individually. However, all the variables are related to each other in real world. Due to the assumptions made and non-relativity of variable value inputs, the analysis is incomplete as it still has chances of errors and it may give depth to the forecast without considering the breadth of it. Examples of sensitivity analysis. For better understanding of sensitivity analysis, it is important to discuss some assumptions based examples that may be applicable in the real time scenario. Number 1. Let us assume a sales manager Rahul who works for a domestic product company and wants to understand the influence of customer traffic on total sales. He determines that sales are a function of price and transaction volume. The price of an underlying product is rupees 5,000 and Rahul sold 500 numbers of them last year. for total sales of rupees 25 lakhs. Rahul also figured out that the 10% increase in customer traffic increases transaction volume by 5%. He is able to build a financial model based on the obtained information, and sensitivity analysis can be performed on this equation based on what if statements. The application of sensitivity analysis on this financial model helps in determining what happens to sales if customer traffic increases by 10%, 50% or 100%. Based on 100 transactions today, a 10%, 50% or 100% increase in customer traffic equates to an increase in transactions by 5%, 25% or 50% respectively. Let us assume that a company named ABC produces 2 products on 2 machines, where a unit of product 1 requires 2 hours on machine 1 and 1 hour on machine 2. For product 2, a unit requires 1 hour on machine 1 and 3 hours on machine 2. The revenues per product 1 and 2 are rupees 30 and rupees 20 respectively. The total daily processing time available for each machine is 8 hours. Now, let x1 and x2 represent the daily number of units of products 1 and 2 respectively. And then, according to the mentioned conditions, following equations are derived. Maximize z equal 30 x1 plus 20 x2 subject to 2 x1 plus x2 less than equal 8. It is for machine 1. x1 plus 3 x2 less than equal 8. It is for machine 2, where x1, x2 is greater than equal 0. The change in the optimum solution when changes are made in the capacity of machine can be charted on a graph. Now, if the daily capacity is increased from 8 hours to 9 hours, the rate of change in optimum Z resulting from changing machine 1 capacity can be computed as follows. Say the rate of change resulting from increasing machine 1 capacity by 1 hour is a change from point C to point G on the graph. Zg minus Zc divide by capacity change, that is 142 minus 128 divide by 9 minus 8 is equal to rupees 14 per hour. A direct link between the model input resources and its output total revenue is provided by the following computed rate that represents the unit worth of a resource in rupees per hour, that is the change in optimal objective value per unit change in the availability of the resource, that is machine capacity. Through this, we have established that a unit increase or decrease in machine 1 capacity will increase or decrease revenue by rupees 14 per hour respectively. Thus, to conclude, it can be said that sensitivity analysis is a powerful tool used in various fields applied on scenarios and models to help decision makers by providing appropriate insight into the problems associated with a given scenario or a model. It also provides us an idea about how sensitive is the optimum solution chosen to variations in the input value of one or more independent variables. The following are the concluding key points for sensitivity analysis. It determines how different values of an independent variable affects particular variable under a given set of conditions. It helps in identifying and eliminating the sources of uncertainties in a given model and helps in making it better, efficient, predictable, and eventually more reliable. By using historical true data, sensitivity analysis allows for forecasting, and important decisions can be made by decision makers by studying all the variables and the possible outcomes. It is useful in making predictions in various important decisions in companies regarding multiple aspects such as operations, production, marketing, sales, etc. Sensitivity analysis is also known as simulation analysis or what-if analysis. In general and in real life, the sensitivity analysis can be used for any activity or system. By keeping the affecting variables and specific boundaries in mind, sensitivity analysis can help all the way from planning a family vacation to making important decisions at corporate levels. So, that is all for today. Hope you have understood. We will meet in the next episode with a new topic. Till then, take care.